Hello students, in this video I'm going to explain work and energy. So as an introduction, just as force has a variety of connotations in common language, so do the terms work and energy. Like in real life we say that we do work, which means that we do exercise. Or we say that we are going to work. This means that we are going to the place where we go where we earn money, where we go to earn money. In real life, we say that we have no energy today. This means that we are tired. Or we do yoga to build positive energy. This means to become optimistic. So how is this related to the work and energy that we discuss in physics? Working or doing exercise allow us to achieve our goals in losing weights, or just as working allows us to do some achievements in work, to finish missions in work. Similarly, in physics, doing work means applying a force causing the displacement of the object. So pushing or pulling, but also this push or pull has to cause the displacement of the object. Otherwise, we won't be considered to be doing work. And as for energy, as energy here is used to explain if we are able to do work or not. Similarly, in physics, energy is the work done per unit time. So it is, we need energy to do work in physics. As a definition, let's get introduced to the definition of each term from the physical point of view. Mechanical work is a scalar quantity that describes the change in energy that takes place whenever an external force is exerted on an object, causing its displacement. So it's necessary that this force cause the displacement of the object. Otherwise, it's not considered to be performing work. So in which figure below does the boy perform work? In figure 1, in which he pushes the ball and it rolls easily, moving from one place to another, or in figure 2, in which the boy exerts a force on the stone trying to move it but couldn't move it. Of course, work is done in figure 1 because the force exerted caused the motion of the ball. In other words, it caused the displacement of the ball. However, in figure 2, no work is done because the force exerted didn't cause the motion of the stone. Our study will be restricted to one-dimensional and two-dimensional motion. So we're going to study objects that move in one dimension, horizontally or vertically, or that move in a plane. We have now to recall the concept of a force, the definition, representation, characteristics, and types. A force is a push or pull exerted by one body on another body. It is represented by a vector, as you can see. The push exerted by this man on the car is represented by this orange arrow showing the line of action and the direction. Characteristics: point of application, which could be point of contact if the force is a contact force, or center of the gravity of the object if the force is a force acting at a distance. And in this case, it is the point of contact between the man and the car, this one here. The direction, line of action, is oblique, vertical, or horizontal. In this case, it is horizontal. Direction upward if it was vertical, to the right if it was horizontal, downward to the left if it was oblique. In this case, the force is to the left. Magnitude, which describes the intensity or the strength of the force. Its SI unit is in Newton, and the symbol of the SI unit is capital N. Formula: the work done by a constant force vector F vector is equal to the scalar product of the force vector and the displacement vector D. In one-dimensional motion, the magnitude of the displacement vector is the distance covered by the object under the action of the exerted force. Here I would like to note and to stress on that this force must be a constant force. What do I mean by constant force? Having the same direction and the same magnitude, because when we describe a vector quantity being constant, this means that both its magnitude and direction has to be constant. Now if this is satisfied, we can apply the formula W equal F vector dot D vector. This is what we mean by scalar product. It's a dot product, which is equal to the magnitude of the force vector times the magnitude of the D vector times cosine the angle in between. So W is the work, F is the magnitude of the force, D is the distance covered by the object, and FD within parentheses is the angle between the direction of the force and the direction of the displacement vector. This is a table that sums up the symbols, the SI unit and symbol of SI unit. Symbol of work W, capital W, symbol of SI unit of work is joules. Symbol of SI unit is capital J, force capital F, Newton capital N, distance small d, meter m. And the angle between the force vector and the displacement vector is expressed as such, separating the two vectors by a comma and being written within parentheses. And the SI unit is degree, whose symbol is a small circle above to the right of the value. Now another recall here is about the trigonometric circle. Why do we need it? Because we want to recall the sign of the cosine. What do I mean by the sign of the cosine? Whether it's positive or negative. What does this have to do with our lesson? Because simply the formula of the work includes cosine, so we have to be able to deal and determine the cosine of the angles between the force vector and the displacement vector to be able to calculate the work. So this is the trigonometric circle. X-axis corresponds to the cosine, y-axis corresponds to the sine, and the radius is equal to 1 because the largest value that a cosine could have is 1. So if you can see here, the blue one here, this is the angle alpha between this line and the x-axis is 0. So cosine 0 degrees is plus 1. Now another angle here, another line here, which is the yellow segment or the orange one. It forms an angle alpha between it and the x-axis. Okay, so if you do the projection on the x-axis in order to determine the cosine, the sign of the cosine, so downward, projecting it downward, so this is the positive part. So the cosine alpha in this first quadrant is greater than 0, which means it's positive. Then if you consider this red one on the y-axis, the angle between it and x-axis is 90 degrees. Okay, so this is cosine of angle 90 degree. Now if we do the projection from the top to the x-axis, we find that the angle is, that the cosine, is 0. There is no distance away from the origin. It exactly coincides with the origin. So the cosine of 90 degrees angle is 0. If we take another one here and do the projection, the cosine is going to be negative because it's from the negative side of the x-axis, and the angle, if we consider this a black segment, it's making an angle equals 180 degree with the x-axis. So this is cosine 180 degree, it's equal to minus 1 because we said that the trigonometric circle has a radius of equals to 1 in absolute value. Similarly, the third quadrant, the fourth quadrant, the cosine here is going to be negative if the angle is greater than 180, and it's going to be negative from positive from this side. The cosine is positive. If we draw a segment here and project it on the x-axis, it's going to belong to the positive side of the x-axis, so it's going to be positive. In the adjacent document, the nurse pushes the wheelchair by a constant force F equal 10 Newton, moving it by distance D equal 1.5 meter away from the initial position. Calculate the work done by the nurse in this case. Applying the formula, since we are given that it's a constant force, and we are given the magnitude, and we mean that the constant force is constant in direction and magnitude, and we said it's pushing, so the nurse here is pushing it away horizontally because the nurse is moving horizontally. So calculating the work, now we have to apply this formula, work equal F vector dot D vector, which is equal to Fd cosine theta, where theta is the angle between F vector and D vector. So F is given to be 10 Newton, D is given to be 1.5 meter. Now what about the angle between the displacement and the force vector? As you can see here, I represented the force vector, which is a horizontal one, and I represented that displacement vector. Of course, it must be strictly horizontal, but because I'm using a pointer, it's not really straight. Actually, it's a straight displacement because the wheelchair is moving along the horizontal line. So both are directed in the same direction, then the angle between them is 0. So cosine 0 degree is equal to +1, and we get 15 joules. All the values are given in the SI unit, so the work is going to be obtained also in the SI unit.